Okay, let's quickly go through limits at infinity, and then we can have some, we can break. So limits at infinity. I remember our interest here in this section is rational functions. And you know rational function is quotient of two polynomials. So here we deal with limits of the form limit as x approaches infinity of f of x equals to L, or limit as x approaches minus infinity of f of x equals to L. So x is approaching infinity, which means that x is growing larger, larger, and larger, or x is approaching minus infinity to mean x is decreasing further and further. So the two sometimes can be combined and just write limit as x approaches plus or minus infinity of f of x equals to L. So the x is moving towards positive infinity or moving towards negative infinity. So our interest here is when f of x is of the form p over q, where q is non-zero and both p and q are polynomials. So what you normally do for you to compute limits as x approaches plus or minus infinity of a rational function, you divide both the numerator and denominator by the highest power of x in the denominator. So to compute the limit as x approaches plus or minus infinity of f of x, where f of x is a rational function, we divide both the numerator and denominator by the highest power of x in the denominator. We'll demonstrate with an example to illustrate what really that one means. And then before we give an example, a line y equals to b is a horizontal asymptote of the graph of a function y equals to f of x if either limit as x approaches minus infinity of f of x equals to b, or limit as x approaches infinity of f of x is also B. So when someone asks you to find the value of horizontal asymptote, it's as good as asking you find the limit of the function given as x approaches plus or minus infinity. So e.g., find the asymptote, the horizontal asymptote of f of x equals to 5x squared plus 8x minus 3 over 3x squared plus 2. So the solution, horizontal asymptote, is y equals to limit as x approaches plus or minus infinity of f of x if this limit exists. So it's like simply finding the limit of the function as x approaches plus or minus infinity. So limit as x approaches plus or minus infinity of 5x squared plus 8x minus 3 over 3x squared plus 2. And then we follow what we have said as the procedure of solving or finding limits as x approaches plus or minus infinity. You go to the denominator and identify the x with the highest power. Once we have identified that x, you divide each term in the numerator and denominator by that x value, and then use the normal properties of limits to compute the rest of the limit problem. So what is the highest x in the denominator?
3x squared.
X squared. So therefore, you now take that x squared and divide by each term. So this will be limit as x approaches plus or minus infinity of 5x squared over x squared plus 8x over x squared minus 3 over x squared divided by 3x squared over x squared plus 2 over x squared. That's the first step. And this will give us limit as x approaches plus or minus infinity. Now 5x squared over x squared will be 5x squared over x squared.
It's 5.
5. 8x over x squared.
8 over x.
8 over x. And then minus 3 over x squared. And then 3 plus 2 over x squared. Good. Now, limit of quotient of two functions is the same as? So what is the value of limit from what we discussed previously? f of x over g of x as x approaches a. Is it the same as? Check your book. Limit of quotient of two functions. Volve. So this will be limit as x approaches plus or minus infinity of 5 plus 8 over x minus 3 x squared divided by limit as x approaches plus or minus infinity of 3 plus 2 over x squared. So limit of quotient of two functions is the same as quotient of the limits. So which is the same as limit as x approaches plus or minus infinity of 5 plus limit as x approaches plus or minus infinity of this minus limit as x approaches plus or minus infinity of 3 over x squared divided by limit as x approaches plus or minus infinity of 3 plus limit as x approaches plus or minus infinity of 2 over x squared. So just saying that limit of sum of two functions is the same as sum of limits. So as x approaches plus or minus infinity, the limit of 5 becomes
5.
5. We say that limit of a constant remain to be a constant, regardless of where x is approaching. So the first one will be 5. Then limit as x approaches plus or minus infinity of 8 over x will be okay. I remember before we stopped in the previous class, we had already given this as x approaches infinity of 1 over x. What is the value of this limit?
0.
0. And what is the limit as x approaches minus infinity of 1 over x?
0.
0. And you remember that we said limit as x approaches a of k f of x can be written as k limit of f of x as x approaches a. That constant can always be factored out. So when we have limit as x approaches plus or minus infinity of 8 over x, this you can factor out 8 and write 8 limit as x approaches plus or minus infinity of 1 over x. So therefore, the whole term reduces to what?
To 0.
0. So we'll have plus 0. And then this other part, using the same analogy. Remember, we said that even if I raise this to n is the same thing. So we'll get minus
0.
0. This lower one, first term will be
3.
3. Second part,
0.
0. So the final answer will be
5 over 3.
5/3, correct. So therefore, the horizontal asymptote is y equals to 5/3. So I've shared some books with the class. Please ensure that he shares with you and add more examples on how to compute horizontal asymptotes and how to get at least maybe 5 more examples on computation of limits at infinity and add to the list. And also check how we compute vertical asymptotes. And basically, for you to calculate vertical asymptotes, you simply take the denominator, then equate to 0, and then get the equation. Check how to do that. And then there's also what we call oblique asymptotes. The books I've shared will help you to do this work. And also write on sandwich theorem, which I know you had already done in pure math, but make some short notes on sandwich theorem. So it's called sandwich or squeeze theorem. So give this statement and give, say, 2 or 3 examples on how it is applied to find limits. And get, say, 3 more examples on continuity. So next time we meet, we'll be discussing about differentiation. It's just a revision of what you did in pure math, but we'll have to review some of the different rules or methods of calculating derivatives of functions. Before now, we can go to integration techniques. I hope if we stop there, it's okay. Or what do you think? Do you still have some glucose? We continue or we can stop there? Or I've asked you to do, what I've asked you to do is a lot. Or you can be trusted with that work. Have I asked you to do much? Have I asked you to do much, or is something that you can do?
It's okay, we can do.
Okay, good. So do it in your books, and then next time we meet, we'll be discussing about the derivatives. The 2 books I've shared, they're very good. They can actually help you to master every bit in calculus, what you expected of you. So make maximum use of them. So have a good day and a good weekend as we approach the weekend. So good day.